Thank you for viewing this Danfoss Drives extended startup video. This video will provide startup instructions for a VACON 100 industrial and 100 flow drive, as well as the 100X drive. Please take a moment now to pause the video to read the safety warnings shown here. Failure to follow these warnings could result in death or serious injury.
Hello, I'm Stephen Floyd, a service trainer for Danfoss Drives. In this video, I'll discuss the basic setup and functionality of the VACON 100 Industrial, 100 Flow, and 100X drives. This will include how to access the control units, as well as an explanation of the various terminals and associated default functions. In addition, I'll explain the dip switches used to program various functions in the drive. Next, I'll discuss the basic navigation, usage, and function of the keypad. Finally, I'll demonstrate the functions and provide additional information during this portion of the video. Thanks for your interest in the VACON 100 series of drives, and hope this video will help you in the commissioning, installation, and operation of these drives.
To access the control unit on the VACON 100 industrial and 100 flow drives, release the 4 screws and remove the top cover. Remove the power terminal cover for access to the mains, motor, brake chopper, and DC bus terminals. The drive shown here is a frame size MR5, but access is similar through frame size MR7. Refer to the installation manual for additional information and instructions for larger frame drives. I will discuss accessing these areas on the VACON 100X later in this video. The drive shown here is a frame size MR5. Drives through frame size MR7 are very similar, and access to the control unit terminals is the same. All VACON 100 industrial and 100 flow frame sizes use the same control unit. To reveal the terminals and dip switches, squeeze the tabs on the control box as shown and pull up on the hinged cover. With the control box cover raised, the input-output or I/O and relay terminal blocks are accessible. In addition to the I/O terminals, the optional battery for the real-time clock is located within this control box, as well as the Ethernet port. There are 5 option card slots on the VACON 100 industrial and 100 flow drives. The A and B slots contain the basic I/O and relay terminals, and it's a single card that plugs into both slots. The most common card in these 2 slots, which is known as the F3 card, has 3 output relays, but there is another option card similar to this one, known as the F4 card, that contains 2 output relays and a thermistor input. The card placed in the A and B slots may vary depending upon the original order specifications. The C, D, and E slots can be fitted with various option cards to increase the I/O or add various communication capabilities. The first chart shows the built-in communication protocols that are standard with all VACON 100 series drives. The second chart shows the communication protocols that can be added through various option cards. There are 5 dip switches to configure the analog and digital inputs and outputs and RS-485 communications. These are located on the top of the standard I/O card plugged into slots A and B of the control unit as shown. Starting at the top, the first 2 dip switches define the analog input 1 and 2 signals for either a voltage or current input. The default for AI1 is in the up or U position, which would be a 0 to 10 volt DC input. The default for AI2 is in the down or I position, which would be a 0 or 4 to 20 milliamp input. The third dip switch will define the type of digital input polarity to be used in the drive. The default configuration is in the down or GND position. In this position, all of the digital inputs will have a positive logic. This means that applying 24 volts to any of the digital inputs will activate it or turn it on. This is the most common configuration, but if changed to the up or float position, it allows a negative logic for the digital inputs. This means that applying a ground signal to any digital input will activate it or turn it on. The fourth dip switch defines the analog output signal for either a voltage or current output. The default is in the down or I position, which will be a 0 to 20 milliamp output. If placed in the up or U position, it would have a 0 to 10 volt DC output. The bottom dip switch is used to add a termination resistor when using RS-485 communications. The default position is in the up position, which is off. If needed, the switch can be placed in the down or on position when the termination resistor is required. The VACON 100 series of drives are built with a standard of 6 digital inputs, 2 analog inputs, 1 analog output, either 3 relay outputs or 2 relay outputs and a thermistor input, an Ethernet communication port, and an RS-485 communications interface. Functionality can be increased by adding an additional option card for I/O or field bus expansion as previously discussed. Here we have a close-up of the I/O terminals. When using the I/O terminal strip as the reference location, the digital and analog inputs will control how the drive functions. We will briefly discuss the various I/O terminals and default functions. Starting with terminal number 1, this is a 10-volt DC reference voltage output with a maximum load of 10 milliamps for use with the analog inputs. Terminal number 2 is analog input 1 and is defaulted to receive a 0 to 10 volt DC input. A dip switch setting can change this for a 0 or 4 to 20 milliamp input. Factory default function for this terminal is frequency reference. The motor output speed will be based on a 0 to 10 volt DC input, and it is programmable for other functions. Terminal number 3 is ground for analog input 1. Terminal number 4 is analog input 2 and is defaulted for a 4 to 20 milliamp input. A dip switch setting can change this for a 0 to 10 volt DC input. The motor output speed will be based on a 4 to 20 milliamp input and is programmable for other functions. Terminal number 5 is ground for analog input 2. Terminal 6 is a 24 volt DC 250 milliamp maximum output to be used for the digital inputs and internally connected to terminal number 12. Terminal number 7 is the I/O ground for reference and controls. This terminal is connected internally to terminals 13 and 19. Terminal numbers 8, 9, and 10 are digital inputs DI1, 2, and 3. When activated with 24 volts DC, DI1 is defaulted as run in the forward direction, DI2 is defaulted as run in the reverse direction, and DI3 is defaulted as an external fault. All digital inputs can be programmed for other functions, but this video will only discuss the factory default functions. Terminal number 11 is used as a common for digital inputs 1 through 6. This terminal would be used if disconnecting the digital inputs from ground via dip switch setting if using negative logic. This terminal is internally connected to terminal number 17. Terminal number 12 is a 24 volt DC 250 milliamp maximum output to be used for the digital inputs and internally connected to terminal number 6. Terminal number 13 is another I/O ground for reference and controls. This terminal is connected internally to terminals 7 and 19. Terminal numbers 14, 15, and 16 are digital inputs DI4, 5, and 6. When activated with 24 volts DC, DI4 is defaulted as preset speed 1, which is 10 Hz. DI5 is defaulted as preset speed 2, which is 15 Hz. And DI6 is defaulted as a fault reset. If DI4 and DI5 are active together, preset speed 3, which is 20 Hz, is selected. Like the other digital inputs, these are also programmable for other functions. Terminal number 17 is used as another common for digital inputs 1 through 6. This terminal would also be used if disconnecting the digital inputs from ground via a dip switch setting if using negative logic. This terminal is internally connected to terminal number 11. Terminal number 18 is an analog output and is defaulted for 0 to 20 milliamps, but that can be changed for a 0 to 10 volt DC output via a dip switch setting. This is defaulted for output frequency, but can be programmed for other functions. This will provide an output proportional to the motor output frequency. Terminal number 19 is the analog output common. This terminal is connected internally to terminals 7 and 13. Terminal number 30 is a 24 volt DC auxiliary input that can be used as an external power backup for the control unit. Terminals A and B are for the RS-485 field bus communications. Terminal A is the negative connection and terminal B is the positive connection. The VACON 100 series of drives have various built-in field bus interfaces as previously discussed. Other communication protocols can be added through the use of various option cards. Terminals 21, 22, and 23 are for Relay 1. This relay is defaulted to be active when the drive is in a run state, but it can be programmed for other functions. Terminal number 21 is a normally closed contact, 22 is the relay common, and 23 is the normally open relay contact. Terminals 24, 25, and 26 are for Relay 2. This relay is defaulted to be active when the drive is in a fault state, but again it can be programmed for other functions. Terminal 24 is a normally closed contact, 25 is the relay common, and 26 is the normally open contact. Terminals 32 and 33 are for Relay 3. This relay is defaulted to be active when the drive is in a ready state, but again can be programmed for other functions. 32 is the relay common and 33 is the normally open contact. Note that there is no normally closed contact for relay number 3. To access the power terminals and control unit on the VACON 100X drives, release the 4 or 6 screws shown and separate the two halves of the drive. The top half of the drive is the power head and the bottom half is the terminal box. The terminal box contains the mains, motor, brake chopper, and DC bus terminals, as well as the control unit. The drive shown is a frame size MM5, but access is similar for the MM4 and MM6 drives. Here's a typical wiring diagram of the power connections for a VACON 100X drive. This is a frame size MM5, but the MM4 and MM6 sizes are very similar. The control unit is common among all frame sizes of the 100X drives. The VACON 100X control unit looks physically different than the 100 industrial and 100 flow control units, but shares most of the same functionality. I will briefly describe the variations, dip switches, and the I/O terminal configurations. Starting in the lower left corner is the Ethernet port. To the left of it is the first of 2 option card slots available on the 100X drives. Above that are the safe torque off terminals, or STO. At the top is the location of the dip switches, which we'll discuss shortly. On the right side we have 2 thermistor input terminals. Below that is the second option card slot. On the bottom right are the 2 standard relay output terminal blocks. Finally, in the bottom center are the I/O terminals and RS-485 field bus communication terminals. There are 5 dip switches to configure the analog and digital inputs and outputs and RS-485 communications. These are located at the top of the control unit. Starting from the left, the first 2 dip switches define the analog input 1 and 2 signals for either voltage or current input. The default for AI1 is in the down or V position, which would be a 0 to 10 volt DC input. The default for AI2 is in the up or C position, which would be a 0 or 4 to 20 milliamp input. The third dip switch defines the analog output signal for either a voltage or current output. The default is in the up or C position, which would be a 0 to 20 milliamp output. If placed in the down or V position, it would have a 0 to 10 volt DC output. Note that analog input 1, analog input 2, and analog output dip switches have a middle or 0 position. This is a factory test mode that should not be selected and may have undesirable results if used. The fourth dip switch will define the type of digital input polarity to be used in the drive. The default configuration is in the down or 2 position. In this position, all of the digital inputs will have a positive logic. This means that applying 24 volts to any digital input will activate it or turn it on. This is the most common configuration, but if changed to the middle or 1 position, it allows a negative logic for the digital inputs. This means that applying a ground signal to any digital input will activate it or turn it on. The up or 0 position will be used if the digital inputs are to be isolated from ground. The fifth dip switch is used to add a termination resistor when using RS-485 communications. The default position is in the down or 2 position, which is off. If needed, the switch can be placed in the up or 0 position when the termination resistor is required. The middle or 1 position is used for biasing purposes and connects pull-up and pull-down resistors of 10 kiloohms. Here's a close-up detail of the VACON 100X I/O and relay terminals. Most of the terminal numbering is identical and has the same functionality as previously explained for the VACON 100 industrial and 100 flow drives. The 100X contains a standard safe torque off or STO terminal strip as shown on the left side of the drawing. It contains 2 separate digital inputs and isolated feedback terminals for functional safety features to bring the motor to a no torque state when activated. The 100X drives do not contain a standard third output relay. Instead of a relay, terminals 28 and 29 are used for a PTC thermistor input to monitor the temperature of a motor, other equipment, or other process. Refer to the user's or installation manual for detailed information regarding the terminal functions and connections, or download a copy of the manual from danfossdrives.com. All of the VACON 100 series of drives share a common look and feel for the keypad. Here we will briefly talk about the various buttons and displayed information. Later in this video, we will see an actual demonstration of navigation through the keypad on a VACON 100 industrial drive. Starting on the lower right, pressing the green button will initiate a motor start or run command when the drive is in keypad mode. Pressing the lower left red button will initiate a motor stop command. The default operation of this button allows it to provide a stop command regardless of the control place, meaning it will stop the motor if being controlled from the keypad, I/O terminals, or field bus. This can be changed to function only in keypad mode from the parameter menu if needed. The OK button can be used to enter an active menu level or item, or confirm a selection such as when editing a parameter value. The back reset button allows a backward move in the menu, exiting the edit mode, or resetting a fault. The FUNCT or function button is used to access the control page. The control page can be used to change between the local and remote control places, change the motor rotation direction, or to select the quick edit function that will allow entering a specific parameter or monitoring ID number and directly access that value for editing or viewing. The left and right arrows allow moving the cursor left or right when editing a parameter value. This allows editing a specific digit to make programming faster and easier. The up and down arrows allow scrolling up and down through the menu items, or can be used to increase or decrease a value. The VACON 100 industrial and 100 flow drives contain an LED indicator located directly below the keypad for additional indication of the status of the drive. A slowly blinking green LED indicates that the drive is in a ready state and all conditions have been met for the drive to run. A solid green LED indicates that the drive is currently running, and a quickly blinking green LED indicates that a software update is being processed. A solid red LED indicates that a fault condition has been tripped and the drive is stopped. A solid orange LED indicates that an alarm condition has been met, but the drive is able to continue running until a fault level has been reached. The VACON 100X contains 4 LED indicators in the lower left corner of the drive. The yellow PWR LED indicates that the drive is powered up. The green Run LED indicates that the drive is currently running. The red FLT LED indicates that a fault condition has been tripped and the drive is stopped. The yellow RDY LED indicates the drive is in a ready state and all conditions have been met for the drive to run. The LCD display is used to indicate the status of the drive and how it is being controlled, viewing or editing parameter menus and values, and monitoring of various drive input and output values. The graphical display keypad shown here is the most common type of keypad, but there is a text display keypad available. Refer to the appropriate operating guide for detailed information on usage and explanation for the type of display you are using. Operating guides are available at danfossdrives.com. The following information applies to the graphical display keypad shown. Starting from the top left, the first item is status field 1, which indicates if the drive is in a run or stop state. The next block indicates the motor rotation, either clockwise or counterclockwise. The next item is status field 2, which indicates if the drive is ready, not ready, or a fault has been detected. Next is the alarm indicator, which will indicate if an alarm level has been reached. The top right block indicates where the drive is being controlled. This will show PC if being controlled from a computer, I/O if being controlled remotely from the I/O terminals, keypad if being controlled locally from the keypad, or field bus if being controlled remotely through field bus communications. The next line down provides text to indicate the menu category level currently being accessed. Below that is the location field. This provides the ID number of the parameter or value and the current location within the menu structure. The fields below that are the groups or items associated with the menu category listed. The dark colored block is the activated group or item. Using the up or down arrow buttons will allow scrolling to the desired block. Pressing the OK or using the right arrow will allow viewing or editing the selected item or allow you to continue further into the menu group depending on the current location in the menu structure. Here is the basic menu structure for the VACON 100 series of drives. Note that this menu structure may vary slightly depending on the type of VACON 100 drive you're using, but the majority of this structure applies to the entire VACON 100 series of drives. I will discuss some of the most common basic menu items when I show the operating portion of this video. Here's a basic wiring diagram showing the default functions of various inputs and outputs. This basic diagram is the same for the VACON 100 industrial and 100 flow. The 100X is very similar, but does not have relay number 3 as we discussed previously. The diagram is shown as I actually have it connected to an I/O simulator that I will be presenting in the video. From this basic diagram, we see that terminal numbers 1, 3, and 5 are the analog input 1 and 2 reference voltages. Terminal number 2 is the analog input 1 signal input, and terminal number 4 is the analog input 2 signal input, both for speed reference as default. Terminal number 6 is the 24 volt DC used to activate the 6 digital inputs. Terminal numbers 8, 9, 10, 14, 15, and 16 are the digital inputs number 1 through 6 with the default programming shown. Terminal number 13 is a ground for the lights hooked up to relays 1, 2, and 3. Terminal number 18 is the analog output plus, and terminal number 19 is the analog output common, which is internally connected to ground, both of which are connected to a meter for indicating the output frequency. Terminal numbers 23, 26, and 33 are the normally open relay contacts for RO1, 2, and 3, with the default functions also listed.
Now I'm going to perform a demonstration on an actual drive here. So I've powered up the drive, and when I powered it up, it came up to this main menu, and from the main menu we have access to all of the other parameters and values that we can either edit or view. What I want to do is bring this drive back to factory default settings. So to do that on this drive, from the main menu, I'm going to scroll down using the up and down arrows until we get to user settings. One of the features with this drive is there's a number in parentheses underneath the item. It tells you how many menu items are within that level. If I hit OK, we come up to the user settings menu, and we've got a number of different items within that menu. And in this case, I want to go to parameter backup. If I hit OK, the first item that's on here is restore factory defaults. If I hit OK, we can activate it. There's a help menu there. There's also an add to favorites item. If I want to go down and see what restoring factory defaults means, I can hit OK, and it says restores factory default settings. It also will restart the drive if the motor is not running. OK, we go back and we're back to restore factory defaults. Hit OK again. Here I hit activate. Now all the parameters are being reset back to factory defaults. When this finally powers back up, the menu will be at a quick startup level, and we can change some of the various information right here at the beginning. This is also the screen that you should see if you're setting up a new drive. So the first item here is our language selection. I'm going to choose English. If this had a battery for the real time clock, which this one does not, then it would ask for items such as the date, the time, daylight savings, those types of things. The next thing after that is the startup wizard. I'm going to say yes to the startup wizard. And here we can choose which application we want to load into this drive. So we have a choice of standard, local remote, multi-step speed, PID control, multi-purpose, or motor potentiometer applications. I'm going to go with the standard application. So I hit OK. The next question is, what type of motor do you have? Is it an induction motor, permanent magnet, reluctance motor? The one I have hooked up is an induction motor, so I hit OK. The next thing it asks for is the motor nominal voltage. This would be off of the motor nameplate. So in this case, it is a 230 volt motor. What is your maximum, or what is your nominal frequency based on the nameplate setting? It is 60 Hertz. What is my motor nominal speed? I'm going to change that to the motor nameplate setting, which in this case is 1600 RPM. And you see I can use the left and the right arrows to select specific digits. If I hit OK, I go on to the next one. My motor nominal current, in this case it's a very low current motor, so I'm going to bring this down to the minimum level. The minimum for this drive is 0.66 amps. I hit OK. Motor cosine of phi, again off of the motor nameplate. 0.80 is OK for this motor. Now what is my minimum reference speed? What is the minimum speed that I want this motor to run at? And I'm going to leave it at 0 Hertz. My maximum reference, defaults to 60 Hertz. I can set that higher than 60 Hertz. I can set it lower than 60 Hertz. I'm going to change this to 62 Hertz. Okay. Acceleration time. How fast do you want this to get up to full speed? In this case, I'm going to say 3 seconds. My deceleration time, the time it takes to get from full speed to 0 speed, I'm going to say 3 seconds again. Application wizard. So again, we're going to go into that. The next question is for selecting from where the start-stop commands and frequency reference is given. Hit OK. And do I want the I/O terminal, field bus, or keypad? In this case, I do want to go with the I/O terminals. Hit OK. So the message given in I/O terminal control frequency reference can be given either by AI1, 0 to 10 volts, or AI2, 4 to 20 milliamps. I actually have analog input 2 set as a 0 to 10 volt reference as well. I can scroll down to the next message if there is another message. So this just says press OK to continue or back to cancel. The next thing that comes up tells you what the current configuration is that you've selected. So analog input 1, which is on terminals 2 and 3, is set for frequency reference. Analog input 2, terminals 4 and 5, frequency reference. Digital input 1 on terminal 8 starts forward. Digital input 2 is starting in the reverse direction. Digital input 3 will provide an external fault. Again, that's when 24 volts is applied to any one of those terminals. I see I have a scroll bar over here, so I can scroll down. We see that digital input 4 on terminal 14 is set for preset frequency 1. Digital input 5 is set for preset frequency 2. And digital input 6 is set for fault reset. Again, these are all digital inputs that are freely programmable for other functions. I'm going to be presenting just the factory default functions. Also, analog output 1 is set for output frequency. So I have a meter on my I/O simulator with a gauge on it that will show me a proportional reference of the actual output speed. I can scroll down again, and then we'll have our relays, how they're programmed. So when relay 1 is enabled, it tells you that it's in a run state. Relay 2 is in a fault state, and relay 3 would be in a ready state. Press OK to continue or back to cancel. So I'm going to hit OK. Wizard is ready. Press OK to exit. Now that we have our basic setup input, the next thing I want to do is save all of these parameters to the keypad. So we're going to go back to the same menu, which was the user settings, parameter backup. We can save it to the keypad, restore it from the keypad. We have 2 sets that we can save it into. We can save it to set 1 or restore from set 1. We can save it to set 2 or restore from set 2. In this case, I'm just going to save it to the keypad. OK. Again, help if you need some information. Save parameter values to keypad to copy them to another drive. So that's an easy way to save your parameters so that you can input them to various other drives if you'd like to. Hit OK. Save to keypad. Parameters have been saved. Press OK to continue, and we're finished with backing up the parameters to the keypad. So I just hit the back until we get back to the top level of the main menu. Now I want to run this in keypad mode. So right now it shows that we are in I/O mode. In order to change that to keypad mode, I just hit the local remote button and scroll down to the local remote item, hit OK, and here we can decide, do we want it in local or remote, and I want to go local, which would be keypad. And now it brings up the monitor screen here, shows us we're in keypad mode. Here I can change my keypad reference, hit OK, and I can bring that up to whatever speed I would like it to run at. In this case, I'll say it's 60 Hertz. I hit OK. When I hit the green button, this motor will take 3 seconds, and it should ramp up to full speed of what I have set. We see that output frequency says 60 Hertz. My motor speed, approximately 1780 RPM. Motor current, shaft power. These are all editable fields. You can display what you'd like there. That screen is available here when you hit the local remote and go to control page. That's the screen you would see. I can hit stop, and this will stop the motor. We see that there's no output frequency, speed, or anything else listed here. Again, up here we show stop, we show what the motor rotation was. It is in a ready state right now, running on keypad. We're in keypad reference, which is this ID number 184. We can also go into the monitor mode, which is the next item down. The multi-monitor is very similar to that control page. This also lists a number of different items, all editable for whatever particular item you want to display on that screen. I hit run again. We see the same basic information. Now I want to run this using the I/O terminals. So the first thing I'm going to do here is go back to the local remote and change this from local to remote. And right now it shows that I'm on the I/O terminal strip. And I can also go to that same control page, and we can see the information displayed here based on the I/O, the analog inputs. So right now I'm bringing these analog inputs the whole way down to 0. If I bring up analog input 1, we can see that there is a change in the frequency reference. Bring that back down to 0. Do the same thing with analog input 2. And we see that it also responds as a frequency reference. So the drive is not running at this point, but I turn digital input 1 on. Now it shows that it is running. We have a 0 frequency reference, so the motor is not spinning. But if I bring one of the analog inputs up, we can see that it is now running. And I'll bring that up to full speed. We see our output frequency. This was our reference. This is what it's actually running at. There's our RPMs, our current, and shaft power. I'm going to bring that back down. Turn digital input 1 off. And I'm going to turn digital input 2 on. Digital input 2 is a reverse, and we'll see that it shows a negative reference. So we're running in reverse with a reference of negative 62 Hertz. Output frequency is negative 62. Motor speed is a negative value. And again, same values for our current and shaft power. I turn digital input 2 off. Turn digital input 1 back on. So right now I have a frequency reference of about 35 Hertz. If I turn digital input 4 on, digital input 4 is a preset reference. The default value is 10 Hertz. I turn that off and turn digital input 5 on. Digital input 5 is a preset speed reference of 15 Hertz. And when I turn 4 and 5 on, we have a preset reference of 20 Hertz. If I turn those back off, we're back to being controlled by the analog inputs. I can create a fault, external fault in this case. We can see that the keypad display is flashing. We have a fault listed here. We also have a red LED showing here. So I'm going to turn digital input 3 off. Hasn't cleared yet, but I can use digital input 6 as fault reset. And once I do that, we're back to a ready state. I created another fault here. I can also use the back reset button to clear that fault. You may have to push and hold this for a second, and it should reset. Note that not all faults will be able to be cleared using the fault reset, either the digital input or using the reset. Depends on the type of fault. Some require a drive power cycle. Some of them, if it's a serious fault, may not be able to be reset at all, may have to be sent in for service. Now I'm going to discuss the quick setup menu. The quick setup menu is the first menu found under the main menu, and we can see that there are 31 items associated with this group. If I click OK, we see that the first item is wizards, and we have the startup wizard, multi-pump wizard, and fire mode wizard. The startup wizard is the same wizard that we used just after we had reset all parameters back to factory defaults. You could activate that, just click OK, and then activate. The multi-pump wizard and fire mode wizard we'll not discuss in this video, but a detailed explanation can be found in the user guide that can be downloaded from danfossdrives.com. A number of these items will be things that we have already set during that startup wizard, such as the application, but it could be changed here. We can change that to whatever, and we have the same options to pick from. I'm going to keep it as standard. There's our minimum frequency reference. We had selected 0 Hertz. Our maximum frequency reference, we had selected 62 Hertz. The acceleration and deceleration time, we had selected 3 seconds. Current limit is a new parameter we haven't done yet, and we can go into that if we wanted to change that to something other than 8 amps, which is a default level. In this case, I'm going to change this to 1 amp. Click OK to accept it, and then back. And now you see that the value has been changed. Next item down is the motor type, and we had selected induction motor during that startup wizard. I'm going to leave it as that. The next items will be from the motor nameplate. So we have motor nominal voltage, 230 volts, motor nominal frequency, 60 Hertz, motor nominal speed of 1600 RPM, motor nominal current 0.66 amps, motor cosine of phi 0.80. Energy optimization is disabled. If you wanted to enable that function, you can do that right here. Motor identification. The motor identification will fine-tune the drive to match the connected motor and cabling. It provides the drive with a more accurate motor model than just entering the standard data in the parameters. Start function, we can select from ramping or flying start. I'm going to leave it as ramping. Flying start would allow you to start the drive in a motor that is already rotating. Stop function, either coasting or ramping. Coasting is the default, but we could change that to a ramping stop if we wanted. Automatic reset, we can enable or disable, and from defaults this is a disabled feature. External fault, we can decide how we want to deal with an external fault. Default is it faults the drive and it stops it from running. Or we could select fault and coast instead of a ramp. We can give an alarm, or we could do no action. I'm going to leave it as a fault. Analog input low fault. If there is a fault in the analog input, what would you like the drive to do? And if you're not sure, again, we have this help. Use this parameter, select the response of the drive to an analog input low fault. And we see that we have no action, alarm, alarm preset frequency, alarm previous frequency, fault, fault coast. The remote control place, which we had set during the startup wizard for I/O control. Reference for the I/O is analog inputs 1 and 2. That can be changed. There are a number of selections here we can select from. I'll leave it as analog input 1 and 2 together. Keypad reference select, I'm going to keep it as keypad reference. Field bus reference select, leave it as field bus. Analog input 1 signal range. We can change that from a 0 to 10 or 0 to 20 milliamp to a 2 to 10 volt or 4 to 20 milliamp if we'd like. Same with analog input 2 signal range. Relay output 1 function. Right now it's set up as a run for defaults. Relay output 2 fault. Relay output 3 ready. Analog output 1 function is for output frequency. Standard, this gives you the ability to change your preset frequency reference levels. So as we see, we have 10 Hertz, 15 Hertz, and 20 Hertz for frequencies 1, 2, and 3, which is when we enabled digital inputs 4 and 5. And then we're back to the beginning again. Now I'm going to discuss the monitor menu. Next item down, we see there are 11 values in there. There's the multi-monitor we looked at before, very similar to the control page. If I run this drive, we can see all of the various information associated with running this particular motor. We have a trend curve. We can go into that and we can monitor two separate signals in graphical representation. Basic gives you monitoring of various inputs and outputs on this. So if I enable this, we see our output frequency, what our reference is, current, torque, power, motor voltage, our DC link voltage, temperature, lots of monitoring information there. Some of the other items, again, refer to your manual. There are just too many to go into in this video. Now I'll discuss the parameter menu briefly. We go into the parameter menu, and I'm not going to go into all of these menus here. We see we've got specific parameter groupings for various functions in the drive. So we have motor settings, start-stop setup, references, ramps and brakes, I/O config, field bus data map, prohibit frequencies, supervisions, protections, automatic reset, application settings, timer functions, PID controller, external PID controller, multi-pump, maintenance counters, fire mode, motor preheat, drive customizer, mechanical brake, pump control, and advanced harmonic filter. And then we're back up to the top again. The next menu I want to talk about is the diagnostics menu. Here we see we can get into faults, looking at the fault history or active faults. There are some counters in there, information about the software and the drive. So active faults, just that. So anything that is currently an active fault in the drive. As it is right now, there are no active faults, so folder is empty. The next item down is resetting faults. So just like we did with the back reset button, you could do the same thing here. Fault history. This, the memory is capable of holding up to 40 faults, and you can scroll up or down to get to the fault that you want to look at. When you click OK, you'll see that there's a details of that fault, and here we can get some information about that fault. So we know that the code was a 51, the ID number was a 1051. That's good information if you need to call into tech support for help in resolving a problem that you're having with a fault. This could help them identify where the fault is coming from. Also information on date and time that it occurred. So if this had a real-time clock battery in it and you had set the time and date, this would record when that actually occurred. The operating time that it happened, the conditions that were in effect at the time the fault occurred, so motor current, your frequency reference, voltages, things like that. So again, all good information that may need to be passed on to tech support when trying to resolve one of these issues. Then we have total counters. So total energy counter, the amount of energy used by this drive in the time that it was used. We have operating time in years, days, hours, and minutes. The amount of time that the drive has been in a run state, and the amount of time that the drive has been powered on. How many start commands this drive has seen in its lifetime. So that's the counters. The next item, trip counters. Next item, software information. Information specific to the software that's installed on this. So we can see that this is VACON 100 industrial software. It gives you the software package number. Drive information gives you voltage and current, what the drive was built as. Unit status. So a number of items within that diagnostics menu that may be very helpful. The last item I want to talk about is the favorites menu. The favorites menu is a place where you can store some of your frequently accessed items, whether it's a parameter or a value. As it is right now, the folder is empty because we haven't added anything, but we can again add any parameter value or a monitored value into this. So I'm going to go into the quick setup, and I'm going to add my maximum frequency reference. It says it was added to the favorites. I'm going to add a monitored value. I'll say motor speed. and I'll say motor voltage. So now that I've added as many of these parameters or monitored values I want to put into the favorites menu, they always will be able to be viewed or edited from this favorites menu. So we can see those three items have been added in here. If I want to go in and edit one of them, I can go in and edit it just like I could any other value within one of the other menus. So that's it for the VACON 100 basic setup video. I hope this has been helpful. Again, this is Stephen Floyd, service trainer with Danfoss Drives, and thanks for viewing.
Thank you for viewing. We hope this information has been helpful. Danfoss Drives can provide additional technical support, parts information, or repair services options by contacting us through one of the following methods. For immediate access to customer service or a technical support expert in North America, call 1-888-DANFOSS or 1-888-326-3677 or contact us through email. For technical support, the email address is drives.ts.na@danfoss.com. For customer service, the email address is drives.cs.na@danfoss.com. For after-sales service, the email address is drives.ts.service.na@danfoss.com. Additional information is also available on our website at www.danfossdrives.com. For contact information in areas outside of North America, please visit our global website at www.danfoss.com. Thanks again.